So we're going to take a look at the 2008 chapter competition for math, sorry, 2018 chapter competition for math counts. And I'm going to break this into two videos, or maybe more. I'm going to do problems 1 through 5, and then I'm going to take a look at, or we're going to take a look at some of the other ones. So here we go. Question 1. How many ways can you get 27 cents using quarters, dimes, nickels, and pennies? And we're only allowed to use an odd number of coins, so no even number of coins. Now, I'm going to use Q's for quarters, D's for dimes, and P's for pennies. And it's important to have an organized way of counting these so that we don't miss any possibilities, because that's the biggest problem when we do these problems. So if I have 1 quarter, well, I can't have any nickels, but I could have 2 pennies. So that's 1 plus 2 pennies, so that's 3. So that works. So that's one way. I can't really have a quarter in anything other than 2 pennies to get 27 cents. So then what happens if I have 2 dimes? So 2 dimes, I could have 2 pennies. Well, 2 dimes plus 2 pennies, oh, and a nickel. Yeah, well, that's 2 plus 1 plus 2. That's 5, so that will work. So I could do 2 dimes, and then I could do 7 pennies. So 2 dimes plus 7 pennies, well, that's a total of 9 coins, so that works as well. I can't think of any other ways to have 2 dimes, so let's look at 1 dime. So I could have a dime, and I could have 3 nickels, so let's have the most number of nickels I can have. And then that gets me 25, and then I could have 2 pennies. Well, that's an even number of coins, so that will not work. So I'm going to strike that one out. So then, all right, so then we know why that doesn't work. So we could have 1 dime, 2 nickels, so that's 20 cents, and 7 pennies, and that gives us a total of 9, 10. Oh, geez. Yeah. Shoot. No. 9, 7 plus 2 is 9. Uh-oh. So then we could have a dime and 17 pennies. That's 18 total coins, so we know that one doesn't work. So then we could have we have 5 nickels and 2 pennies. Well, that's going to work out just fine for us. We could have 4 nickels and 7 pennies, 3 nickels and 12 pennies, 2 nickels and 17 pennies, 1 nickel, and that would be 22 pennies, and we could have just 27 pennies. So this is even, right? It doesn't work. So we get 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different ways. Okay, so next problem. The degree measures of the angles of a hexagon, and it gives us 1, 2, 3, 4, 5, 6 angles. What is the degree measure of the largest angle of a hexagon? Okay, so a hexagon has 6 sides. Well, we know that 180 degrees times n minus 2 is going to give us the number of degrees in the polynomial. And so 6 minus 2 is 4. 4 times 180 is 720. So we know that 720 is equal to x plus 10 plus 2x plus 80, 3x minus 60, 4x plus 40, 5x minus 10, and 6x minus 33. Well, that gives us a total of 21 x's and 27 left over. All right, so we know that this is equal to 720 minus 27 minus 27. And you get 21x is equal to, checking my notes here, or I could just pull up a calculator. That'd make a whole lot more sense. So that is equal to 720 minus 27 and then divide by 21, and we get 33. X is equal to 33. Now that's not a measure of an angle, that is this x value. So intrinsically, I want to say 33 times 6 minus 33. And I would get a total of this angle being 165. But this minus 33 is kind of worrying to me. I think we might be able to get something larger. So I'm going to look at the last, or the first term here that has a plus. So let's try the 4x. So 4 times 33. Well, 4 times 33 is plus my 40, and I already know that's going to be bigger. So we have 172, and that was 9. All right, for number 3. Oh, I love these little puzzle problems. So we have the numbers 11 through 21 inclusive. That means we're not skipping any numbers. And they're all placed on this wheel. Has someone else seen Dude Perfect and Wheel Unfortunate? It's great.
What about the Wheel Unfortunate?
We've got the Wheel Unfortunate right here. Hopefully,
So unfortunate.
well, it's not. It's actually a fortunate wheel.
Would you like me to include, like, on this answer where it's a repeating decimal, would you like me to put, like, a repeating sign over it, or do you just, like, repeat the...
I'm not sure what it wants.
Okay.
I don't know. I'm sorry. All right. So, and it gives us a little hint that there are different possible ways because it wants the greatest value of the sum. So we're essentially adding pinwheels here. So if I want the greatest possible way, oh, and do you want an explanation on this now?
I have to go. Like,
Oh, okay. I have a good practice. So we know that the number in the middle has to be the largest possible number, 21. And that means I want to have the largest number and the smallest number across from each other. So here's an 11, here's a 21, no, 20, because I've already used my 21. And I add those together and I get a grand total of 42. Just to double check, my next largest would be 19. My next, that'd be 12. Add that together and lo and behold, I get 42 again. So let's just double check. I'm worried about, oh, it's 52. I'm an idiot. This is what happens when you do things with no break all day. So that's 52. And I can prove it because 20 plus 21 plus 11 is 52. All right, this next problem, I really like this next problem. Has all the stuff that I love about quadratics. So we have a binomial pair, and we know in its expanded form, we get 7x squared plus 9kx plus 5y squared. And we're trying to find the value of k. So let's go ahead and multiply it out. So ax times cx is acx squared, which means a times c must equal 7. So that means one of them has to be a 7 and one has to be a 1, because we know that we only have integers. Multiply this out here, and I get a d times xy. Multiply this together, And I get BC times XY. And over here we get BD times Y squared. And when I know BD has to equal 5, so that means one of them is a 1 and the other one's a 5. Okay. Now, adding this together, well, I can't really add these together because I have these variables, but I know what A, C, and D have to be. I just don't know what order it is. So, well, let's say A is 7, and we're saying D is 5. We're saying that's a 1 and a 1. Now, incidentally, it wouldn't matter so much. You're always going to end up with the right answer here. So 5 times 7 is 35. That's still xy, of course, plus 1 xy. So that means that's 36 xy. Well, 9 times k is 36. 36 divided by 9 is 4. So k has to be 4. All right, last problem on this side. At a middle school play, tickets for children under 10 years old cost half as much as tickets for seniors 60 and over. So that means, if I'm going to make a little chart here. So a child's ticket is going to equal, well, seniors' tickets are 2 times as much, right? And then it goes on to say that the adult tickets are twice as much as this. So I know that twice as much as 2 is 4, so the adult tickets are 4 times as much as a child's ticket. So I know that if I have the cost of the child's ticket times the number plus the number of people who have the adult ticket times 4 times the child's ticket plus the number of seniors times 2 times the child's ticket, I should get a total of $544.50. So here we go. Here are our children, because this is 6, because it has a 10s digit of 0 and a 1s digit of 6, so this is 6. This is 9, this is 5. Okay, so we have a grand total of 6 children. All right, for the adults, well, the adults are going to be between the ages of 10 and 57 in this case, because we don't have anyone who's 59. And when I add up the total number that we have, well, we have 21 in this row, we have 3 in this row, 9 in this row, 15 in this row, 7 in this row. You add that all up and you get 55. Then for the seniors, we have a grand total of 8. Well, that means we have 6C plus 55 times 4. Well, 55 times 4 is 220C plus 16C is equal to 544.5. All right, so then we add up our C's together and we get a grand total of 242C is equal to 544.5. Divide by 242, divide by 242. We get C is equal to $2.25. And there we go.